All right, so change control. We've pretty much hit this inside and out. So any questions about change control? Right, it should be included in the software development process. Everything has to go through change control. Right, so let's review. Is this the big picture of change control here? Right, request a change, get all your stuff, forward the change request, submit it for approval. Clark Wilson, right?
That's it's compartmentalized for like
separation of duties.
Right, separation of duties.
Well-formed transactions.
For like a bank transaction, right?
It doesn't have to be limited to banking, but
Was that
well-formed transactions, separation of duties, change control. Clark submits the change request. Wilson approves the change request.
Right.
You guys know what CMM is?
The majority model, yeah.
Yeah. Basically, companies get evaluated by a third party, and they look at their business processes, and they basically get a grade of 1 through 5, CMM level 1 through 5. And depending on your grade, depends on which contracts you can actually bid on. So there's high value in actually being, you can want to develop, the new Air Force One. Well, you're probably going to want to have an optimized company because it's predictable, repeatable results, as opposed to, CMM level 1, which basically means, you got some sort of structure, but not much at all. So your levels here are CMM level 1, initial, 2, repeatable, defined, managed, and then optimized. That you basically grade your policies, procedures, guidelines, and best practices within the development process to prove that you can be repeatable, et cetera, et cetera. Software escrow, we've talked about escrowing before, so now instead of escrowing encryption keys, we're escrowing software. Why? Same concept. Make sure that it's available. It only needs to get released in the event that both parties agree to it to be released. Could be for court cases as well. All right. So issues to consider. You got some. It should be next, right? Yeah. There you go. So object-oriented concept. This is a big picture view. COM versus DCOM. Open database connectivity and object linking and embedding. We're going to cover these things. Some easy points here with the knowledge-based and expert systems or artificial intelligence. And then we go into our mobile code, if you will. So, what is object-oriented programming? Remember the old days of programming? You used to open up an editor and type in line 1, do this, line 2, do that, line 3, line 4, line 5. And it was very linear. And every time you wanted to program something or have the program run, you basically had to write the program. Well, object-oriented programming says, well, once you write it once, why rewrite it? Let's reuse these modules of code. So if you want to write a program to pour a glass of water, well, every time you get thirsty, you just have to click on pour a glass of water, and boom, it's done. So it's reusable. So there's better efficiency in theory. More secure, because once you get the right piece of code, you just reuse it. We have object-oriented design and also object-oriented analysis, which is design is make sure it actually does what it's supposed to do, and analysis would be analyzing that what you designed works. What's COM and DCOM? Anybody know? What's 100? Component object model and distributed component object model. So you got the distributed factor of it. So COM, this is object-oriented things within software architecture. It's not a programming language in itself, but it's, for example, operating systems use COM calls or COM requests to find things on a system. So COM would be a call for a system on the local system, where DCOM would be that same COM call but on another system, different machines. So it's application calls or operating system calls to each other. Yes, no, maybe so.
Okay, so basically it's saying that components would be the same thing as subroutines.
Yeah, you want to locate something on your hard drive? You gotta make a COM request. You want to locate something with somebody else's hard drive? You gotta make a DCOM request. Open database connectivity allows you to connect to databases. If you ever set up an ODBC connector, you got to specify basically your database driver, what type of database is it? Is it DB2 or FoxPro, something like that? Oracle, Microsoft SQL, MySQL. So you have to, this is your connectivity between the front end and the back end. It uses a standard set of APIs, basically the database drivers. You ever heard of object linking and embedding? All right, the fact that you have pictures inside PowerPoint is an example of object linking and embedding. You're linking a picture object inside of another object. Or I can add a spreadsheet to this PowerPoint document. So I'm embedding one application inside of another. So documents can be linked or embedded. Link being HTML or hrefs or hyperlinks. Or you can actually embed the image. So like one of the newest versions of PowerPoint, you actually can have videos with inside PowerPoint. That's a form of object linking and embedding. Then you've got dynamic data exchange. This is an older one. It's really the predecessor to object linking and embedding. The nuts and bolts of it, it uses the IPC or IPC $ to communicate. So like your older Windows machines relied on this. But dynamic data exchange. There's a lot of vulnerabilities associated with the IPC $. You literally could interrogate a host and get registry settings and all sorts of cool stuff. Also in ethical hacking, we call it the holy grail of hacking, when you can interrogate the IPC $ as an anonymous user. It's called a null session. It's like pretending you're an operating system, but you're really a user. And then the operating system thinks it's having a kernel-to-kernel conversation, and it just divulges all the information. Would you like some easy points?
Yes.
You got to know expert systems and knowledge-based systems. So an expert system, this is literally where you have a group of experts. They get together, and everybody brings their own data, and then the experts will apply rule-based programming or pattern matching to develop new trends and patterns. So you can solve complex problems, or you can do a what-if analysis. Like for example, if the global temperature rises, the sea level rises. So you would need your humidity database, your topology database, the temperature database, all that stuff. You combine it and you do rule analysis to basically, if we heat up the temperatures, the ice caps melt, and all of a sudden sea levels rise. But it's a knowledge-based system. You have to have the knowledge to write the signature. Remember that from past kilobytes? It's pattern matching or rule-based programming, ifs and thens. If temperature goes up, do this or do that, or else this. If and else.
What was the past kilobytes thing again?
Past kilobytes, it's profile, anomaly, statistical signature, knowledge, and behavior. So we did the last one of the past, which is signature and knowledge base. You have to have the knowledge to write the signature. So you have to have the knowledge of what you want to find, and then you write a rule or a rule-based programming or logic to develop that pattern. But the key to this is you, the human, have to do this. You are the expert. So you have to have subject matter experts. So we use computers as a tool, but all the real intelligence is from the rule writing from the human. It's an expert system. Think of expert as in subject matter expert. Or expert systems. Make sense?
The system's not the expert.
Yeah, the system's not intelligent here. It's you and your data and the rules that you, the expert, create. That's where the intelligence lies. As opposed to a neural network, where now we're trying to make an intelligent computer system. Remember the movie War Games?
Yep.
What was the smart computer? What was the name of it?
Whopper.
The Whopper. Good God. Good God.
Joshua Whopper.
The Whopper. It was Whopper, right?
Yeah. Joshua was named Joshua.
So neural networks, this is basically computers that have the ability to remember and learn from those experiences. So the computer that plays chess against the human, that's a neural network. It's trying to learn the patterns of the human and then develop strategies based on what the human is doing. So, but one of the downsides of this is that the decision making is only as good as the input.
What about Watson?
Yeah. I was going to ask you about Watson. Familiar with Watson?
He was the computer.
A borderline neural network, but the problem with Watson is that they actually had to type in the data to that. So they should have had, the computer should have had to convert the audio to text and then do the analysis. But as you're typing it in, it's basically rule-based programming, which is more of an expert system. So you do rules to eliminate things that aren't in the question. You come up with a handful of results that aren't in those results, and then you can do a probability of which one you think it's that.
Oh,
So the real thing about Watson wasn't so much that it could answer the questions, it was how it interacted with the players and with the host.
Well, it also you didn't have to program it to understand the question, to parse the question, or parse the answer itself,
Right.
to try to discover the question, which is unique. You don't most computers, in terms of being able to do that kind of parsing of a question, don't do that.
He competed against some like congressman or something like that. Like a week later, and the congressman like beat the heck out of him.
Oh, really?
Yeah.
Different sets of questions.
You know what fuzzy logic is? In binary, we have on and off for completely true or completely false.
Well, that is what Watson used to get answers.
Right.
Because he would...
You can see elements of both of these. An expert system says we had to have a database of information, so Watson had to know the database. I had to learn what the questions were, so it did that off of a knowledge base. But it also could interact with people, so it, half neural network too, or qualitative, if you will. You guys know what Java is? Developed by Sun. Type of coffee. It's designed as a platform-independent virtual machine to run on an operating system. Probably know of it when we browse the web. But untrusted applets should run in a sandbox. My dad always used to say, keep the sand in the sandbox. I didn't know what he meant by that until later when I went, oh, Dad, that's what you meant. Keep the unsecure code in a place where it's not going to affect the rest of the operating system. I was like, why don't you just say that, Dad? So hackers have been develop ways for applets to extend beyond outside the boundaries of the sandbox. So you have trusted applets and you have untrusted applets. Trusted applets are basically signed applets, and untrusted applets stay in the sandbox. Then you've got ActiveX. ActiveX is a Microsoft technology designed in response to Sun's Java, which is used to enhance the web browsing experience. But you'd have to download your ActiveX control and run it on your system. So that is the whole concept of trust. So you can combine your your ActiveX applet with a digital signature, and you get a signed applet, or something that Microsoft calls authenticode. Write that down. Authenticode. Oh yeah, right. AUTHENTICODE. Authenticated code. Authenticode. I'm guessing. I can't spell check verbally, so
That's right.
no trust on that one. No confidence. So the problem is you download these applets and you either trust them or you don't. If you're running untrusted applets, who knows what they're doing on your system? They can change, files on your hard drive. They'll do all sorts of malicious stuff. So you, in theory, combine it with the digital certificate so you can authenticate that code back to its source. Now that doesn't mean that somebody could just supply a digital certificate to malicious code, because that certainly could happen too. So malicious code can come in many ways. You got viruses and you got worms. Viruses live in the ground, they replicate on their own, they do not require humans to do what they need to do, but a virus needs a human to interact.
Viruses live in the ground?
Worms live in the ground, and they replicate on their own, without humans. Whether viruses, a virus needs a human to replicate. So, for example, a worm would take advantage of like a remote procedure call vulnerability and spread without ever touching or interfering with a user. But a human has to actually execute the virus. Has to receive an email and say, "Open me," and execute, and then bad stuff can happen. You know what a logic bomb is? Some sort of programming logic or conditional-based thing. So when time runs out, do this. Like delete a hard drive. And you know the story of Troy? Trojan horses? Piece of cake. It's the program that looks good at the surface, but really is doing something bad. And so you can use antivirus packages to detect viruses, worms, logic bombs, and Trojans. So malicious code can do bad stuff. It can delete, modify, hijack systems. All right, you guys know the symptoms of viruses and worms? Probably if you've ever had one, it's good enough. But you can imagine that it can spread through email or file shares or chat networks or even floppy drives. You wouldn't believe how many viruses are still on floppy drives these days. Download stuff from untrusted sites on the internet. All right, so hackers develop malicious code to ultimately hijack systems. You could just use the system for a zombie or a handler or an agent in a distributed denial of service attack. You can go grab files off your hard drive and ship them to you, email them to you. So a virus, right? And you should block file extensions like EXEs and COM files and BBSs and all sorts of malicious stuff. And there's different types of viruses. You got stealth virus, which attempts to hide itself, or polymorphic. What's polymorphic mean?
Changes.
Many changes.
Changes when it replicates.
Right, polymorphic. So it's the same code. Let's do it over here. It's the same code. Logic here. It's code or an object. Make this the object. I'm sorry, that's the message. So in this case, you'd have a piece of code that would, well, I'll do it from the camera. People are scared these things are gonna run away. What I got here, you got a message that interacts with an object to get some sort of result. So the code's going to interact with an operating system. So in this case, you could say that the different examples here, this would be like Windows 95, 98, 2000, XP, which is basically a different operating system that works a different way. But it's the same message. In this case, the message would be x equals 3. So you could go through the math here and just say 3 plus 3 is equal to 6, or 3 times 3 is equal to 9, or 3 divided by 3 would equal 1, or 3 times 3 squared, that'd be 9. 9 times 3 would be 27, right? So you can see that when the same message interacts with different objects, you get different results. And that's how it attempts to hide itself. It's every time it interacts with a different object, it changes its footprint or pattern, if you will. Make sense? Bless you. So if you write, remember, antivirus is a knowledge or signature-based system. So if you write your signature to detect this, well, then it's like saying it's only good on Windows to detect Windows 95. That's going to produce a different pattern on a different operating system. So now that virus signature you worked is not going to be detected on these other systems. Does that make sense? You should know what polymorphic is. Easy points. Easy points. A boot sector virus, guess what that infects?
Boot sector.
Yeah. Or a compression virus, guess when that gets launched? Whenever you launch compression software. Or here's what I always say. Macro begins with an M, Microsoft begins with an M, and Melissa begins with an M. So Melissa is a macro virus. That'll come back up, write that down, thank me for it one day later. Macro is a Microsoft virus. Or Melissa is a macro virus on Microsoft systems, but they all begin with that.
Melissa is a
Macro virus. Melissa is a macro virus.
on the
Microsoft operating system, right? So it infects things like PowerPoint or Excel or Word, anything where you run a macro. Which is why we had, set that stuff to disable nowadays, thanks to Melissa.
Yes.
Stealth virus, right? Telogen virus that attempts to hide the existence to the system. So, for example, here the object is infected. The virus provides a good, clean copy to mask its presence. At least tries to anyway. And then polymorphic, changing virus that produces different copies of itself in hopes of fooling a virus scanner. But I gave you the programming example of the message interacting with different objects, and that's how it gets the changes, or the many changes. So it interacts with each object differently. Boot sector virus infects the boot sector.
Those are the ones that, back in the old days when you used to distribute, or you used to pass packages that had the boot sector, the boot sector on them, then they would
Nasty buggers.
Yeah.
You'd have to clean your boot record. In some cases, rebuild your hard drive. It sucked. I don't miss those days, I can say that honestly.
Yeah.
Macro virus. They can take advantage of things like VB applications or Windows scripting host or a Microsoft Word document. So Melissa is a great, famous example of a macro virus on a Microsoft system. Because it actually infects the application, so it doesn't matter what document you use. If you're using an application on that infected system, that virus does what it wants to do, because it infects the application, not necessarily a document.
Well, and didn't it?
You can pass
One of the
on
problems
to
was it went on to different operating systems.
Right.
So the macro virus worked on Mac and PCs because they both had Windows applications.
Right. Right. So it uses the documents as a way to spread. You got multi-part. Sometimes you'll see multi-part and sometimes you'll see multi-partite. But this is slightly different than a boot sector virus. So think about, here's how I remember this. Partite, kind of like partition. So it not only affects the boot sector, but also parts of the hard drive. So multi-partite, multi-partitions, the partition tables, and that makes me think of the hard drive. It infects both the boot sector and the file system. And you can infect files basically if they're opened or executed.
Well, attach them to, they don't attach them to all files.
To all files?
All types of files.
No, not all types of files. That would be dependent on the type of virus.
Some types of files you can't infect with virus.
True.
So,
That's a form of carrier, right? Agreed. Everybody else agree? Make sense? Like, you have any example off the top of your head, like what can't?
well, a text file can't, but a JPEG could.
Right, okay, so something that's got to be executable.
Well, the JPEG's not executable, but it can have a buffer overflow embedded in it to cause malicious code.
Yeah, or a malicious
So-
link.
Right, so it depends on the file.
Yeah, and text files are,
And that's why when you run on your computer, the Windows scripting host tends to open as a text file, not as an executable. So even though you're opening a script file, you're opening it in a form that cannot execute code. So if I open an infected file, if I open a VBA file in a text editor, it will not run the executable code. So I'm opening it, but it's not executing. So there is a difference between opening a file and executing a file. That's the only point.
right, or changing or modifying.
So if I open it in a form that can't allow it to execute its malicious activity, I can still open it, I can view it, I can see it, but it won't infect my system.
Agreed. Which brings me to another layer of that. You ever use a text-only web browser? Or a non-executable web browser that reads everything as text, or read-only, not executable? There's a program called Lynx, Lynx, and it's mostly used on Linux systems, but you can go to a web page and view it as text only, so zero executables. So I've used that in the past because we'd have to go to malicious sites and look at the code and see where the bad stuff is happening, but you don't exactly want to get your system infected either. So you got to look at it in basically read-only mode or as text. So they have it both for static files, but also interactively between sites or web browser / web server. Worms propagate code by themselves without the need of the human. So you can use things like email to propagate, network shares and hard drives and instant messaging. Not limited to that. Anybody ever use a virus writer, virus code editor, write virus or anything like that? No? They have toolkits, virus constructing toolkits that you can get, and you can literally click a bunch of buttons and clicks, create file, and it'll create a virus for you. Logic bombs, some sort of either programming logic or time to trigger an action. So like Y2K, we thought that was like, the most famous logic bomb. All of a sudden, 2000 comes around and the end of the world, right? There were literally people sitting on the tops of roofs with semi-automatic weapons waiting for like the world to blow up. I'm like, what a bunch of goofballs. Don't they know that they got to wait till 2012? I mean, seriously.
Yeah, here we go again next year, right?
All right, Merry Christmas, by the way. Open your gifts ahead of time. Trojan horse. Story of
It'll be
Troy.
another non-event.
Any questions? Everybody knows the story of Troy? You guys know what Antivirus Software, right? Does it make sense that we pass kilobytes? You have to have the knowledge to write the virus signature. So you have to know what the exploit looks like. You do not write virus definitions based off of vulnerabilities. You write them based off of exploits. If you wrote them on vulnerabilities, everything in its mom would be flagged. You have to write it on the exploit, which is a specific, it's an exploit by a threat agent on that system. And of course, keep the latest and greatest antivirus software. And that's actually kind of hard to account for system-wide. You got 1,000 machines, and you want to make sure everything's got the latest and greatest signature updates. It's actually easier nowadays, but it used to be really hard to answer that question. What is the virus signatures for all my systems? I wouldn't really want an easy way to do that 10 years ago. I'm just now figuring that out.
Well, you could use like SMS or something like that to push it or something.
Yeah, SMS, or there's a variety of updating tools.
Well, then
SMS or WSUS or...
they've got like yeah, exactly. Like if you plug your if you say you've been traveling for a couple weeks, you come in, put your laptop on the network. As it boots up, first thing it'll do is look at your virus definitions, and if depending on how far out of date you are, it'll quarantine your laptop. Won't let you on the network.
Yeah, that's access control products. So they'll basically put you in a quarantine zone, you scan you, virus update you, make sure you got the latest, greatest patches and everything handy and dandy that you need. Then it'll let you participate in the corporate network. The problem with that is that users don't want to sit and wait to get their stuff updated. right, so you got denial of service. You guys know what that is. Smurf. Next to Smurf, I want you to write ICMP. Denial of service. Fraggle is Smurf's cousin. It's exactly like Smurf, except it uses UDP as its transport. You'll see that in every class that brings up Smurf should probably bring up Fraggle, and they'll tell you they're exactly the same, except one uses ICMP and one uses UDP. SYN flooding. You know what a SYN flood is? You know what the TCP three-way handshake is?
Acknowledge.
Yeah.
I send a SYN to you, and then you would reply with a
Synac.
SYNAC back to me, which if you add this up, I reply to it, I say, synchronize with me, you acknowledge that. Also, during that acknowledgement, you send your own SYN request, which I would, the third part of the handshake is I would just have to acknowledge your SYN. So it's really, if you want to go left, middle, center, or, left, middle, right, it's a SYN, SYNAC in the middle, and then ACK on the right. So SYN, ACK. SYN's on the SYN side, the ACK's are on the ACK side. But really, this corresponds with that, and that corresponds with that, as far as the three-way handshake. So if you were to send a SYN request to me, what would I do?
Send a Synac.
SYNAC back, right? What happens if you send a SYN request to me with a spoof source address to somebody else?
I wouldn't get it.
I'm going to reply to somebody
Reply to me,
else.
right.
So now what happens if you send 10,000 SYN requests out with the spoof source address of your victim? 10,000 people are going to reply to that, therefore creating a denial of service. See how that works? And so let's test your knowledge here. We talked about firewall architectures earlier in the class. There's one type of firewall that will never detect this, and there's another type of firewall that will detect SYN. What generations for 100 points?
Is it generation? Well, you get two
You can do
types.
generation or the name of it. Either way, you
You've
get it.
got signature based and then others that are.
That would be, I'm looking for like first generation through fifth generation, but the signature would be a type of IDS. And IDS could pick that up, yes. But I need the firewalls, not the IDSs. And they both begin with the letter S.
So remember.
What?
State.
State and stateful. Stateless.
Stateless.
Stateless will not detect a SYN flood or not detect a SYN flood because remember, stateless says, I'm going to check to make sure you meet Max's control list, but I'll let you go and I'm not going to monitor you. Stateful packet inspection says, hey, I got to meet Max's control list, but I'm going to keep my eye on you. And it's going to monitor the three-way handshake. So stateful, if it sees a whole bunch of SYN requests coming in and nothing ever gets completed in its three-way handshake, it'll start flushing out those requests, resetting the host. Make sense now? Stateful and stateless.
Stateless will not.
Stateless will not, right?
Because they don't care about
TCP.
It doesn't care about like confirmed delivery or anything.
Right. Basically, all components of TCP. Question?
I got a question with the Smurf, the ICMP.
Mm-hmm.
A way to counter that, if you block your broadcast at your routers,
Right.
at all of your routers, not just,
Would be a good idea. There's a Cisco command for that is no directed broadcasts,
yeah.
right? Okay.
No, that's what I was asking.
Yeah. That's what you have to. That's one way to do it.
Yeah.
Because a Smurf attack, you ping just like I did the ping of death. I showed you I increased the file size and then I pinged the broadcast address. I was slowly building a Smurf attack there, and basically I started with ping of death, but if you know how a Smurf attack constructed, I was leaning towards more Smurf because I'm pinging the broadcast address with the spoof source address and a large packet. So when I ping that broadcast address, normally that traffic would come back to me, but because I spoofed my source, now I get that reply to go to everybody else. And if I add a large payload to that, it amplifies it in every which way we lose. What's teardrop? How you gonna remember that?
Fragmentation.
Right.
All right.
Because the teardrop is whole inside. And
That's
then,
right. DDoS.
Distributed denial of service.
And what are your keywords?
Distributed many.
But
Bot, good.
Oh yeah.
agent.
Bots,
Agent,
zombies,
handler,
Zombies.
zombies. How do they communicate? What type of networks commonly?
The
IRC.
IRC, exactly. You see, look, you guys got it. You know what I mean. So distributed knowledge service. Let's play find the keyword.
Zombie.
Common target, web servers, or DNS, or well, since ICMP is so popular, it's
ICMP.
yeah. Sends bogus requests to service, prevents legitimate users from gaining access. Right. Here's your Smurf. Basically, it's a type of denial of service attack, targeted an entire network or a broadcast address, for example. So I got to select a victim like Amazon.com, and then I'm going to spoof my source address. We got that piece of it. Ping request to the broadcast address. This example is not entirely correct. A little bit more to it than that. But you could say, hey, one address, target this address. But it's also a private address, so it's not a good idea. I have to talk to Jim about that one. All nodes on the network receive a ping packet sent to the network address and respond to the victim's IP instead of the true source address, and then ends up flooding the victim with lots of network traffic in the form of ICMP. Pieces of cake. Fraggle, just like Smurf, except
UDP.
UDP. Sin Flood takes advantage of that three-way handshake. Agree?
Yep.
And we wrote state and state. If you guys, it's probably a little late to tell you this, but I have you guys write the notes on the summary slide here. Like I tell you guys to write stuff next to these, so that way you use these summary slides as more of a quick one-liner of all your keywords and stuff like that. But yeah, you really can find each piece of it in here too. I'm just doing summary slides for you for your notes. Probably should have said that earlier in the week.
On a sync flood attack, you sent out a request and it gets acknowledged. But if it didn't get acknowledged and the request just kept going out, would that be some form of denial of service because it would create an event that would never be responded to?
Well,
So
I think of it like, normally you would send a SYN request to me, I would reply with a SYNAC, and then you would send your final SYNAC. But because I know who you are, I know where to send the traffic. So if you send out 10,000 requests to 10,000 different machines, and you spoof your source address, now all 10,000 of those requests are going to come back to a victim.
Right.
So it's concentrated at the destination, not necessarily from the source.
Okay.
And of course, you'd want to have a large payload. You ping your broadcast address and spoof your source address. All of that really makes up the characteristics of the Smurf. It's kind of an older attack because we don't do directed broadcast anymore. Or you shouldn't anyway. So, teardrop. Should have the word fragmentation here.
What?
Reduces the maximum transmission unit below the normal standard. So when that happens, it has to break it down into smaller pieces and then send it through because it's too big to go through normally. If the protocol stack does not check for smaller than accepted sizes, this may cause the system to freeze or reboot. This is well known, I think it was Windows 95. It could be Windows 98. I think it was Windows 95. The Windows systems didn't like this one at all. It couldn't reassemble the packets because either they were missing pieces or they were overlapping pieces. And when it tried to put it back together, it became a malformed packet and would crash.
Deal with that.
Yeah. Was it Windows 98 or 95?
I don't remember.
Yeah.
Probably
Forget some of the
95.
nuts and bolts sometimes. I think it's Windows 95. All right, zombies, right? Agents, handlers, denial of service. You guys already got that. And give yourself a big round of applause. Yay, we've now successfully completed 5 days of grueling pain.
Following 10 weeks of grueling.
I know, right?
Following, you guys got 10 more weeks to go.